Again, it's a rich thing.
What is going on, guys? Welcome to this AI tutorial. In today's video, we're going to build a chatbot using natural language processing and neural networks in Python. So let us get right into it. Now, before we get into the actual Python code, we need to set up a so-called intents.json file. This intents.json file contains certain categories of things that can happen. For example, the user can greet the chatbot. The user can ask a question about the prices. The user can ask a question about the name of the chatbot, about the creator of the chatbot. The user can say goodbye. And those are all different categories provided with tags. For example, we can have one tag called greeting. And for each tag, we also specify patterns like hi, hello, good day, what's up, hey, greetings, stuff like that. So essentially, we provide a couple of examples how a user could greet the chatbot, and then the chatbot is going to take that as training data and see, okay, this is what greeting me looks like, and I'm going to adapt to it. It's not only going to adapt to the exact things that you put into the chatbot, so it's not going to, if you type hello, it's not only going to recognize hello, but also stuff like hello, how are you? Or similar things. So it's going to adapt also to a little bit more different data. It's not super intelligent. It's not going to always recognize what you're trying to say. But if you provide enough examples like hi, hello, hey, it's going to generally recognize when the chatbot is being greeted. And then we also have responses. So a collection of static responses. Those are not going to be generated. We're not going to have a text generating chatbot here. This is going to be statically typed into the JSON file. It's going to be it's going to be the exact messages that the chatbot returns. So the patterns are going to be more fluid, more flexible, but it's always going to return the exact responses. So the idea is that we train the chatbot to recognize what the user is trying to get from it, and then the chatbot is going to have some static responses to the questions or to the requests of the user. So for this, we're going to create a new file called intents.json, and we're going to start with curly brackets. So we're going to have a ordinary JSON file. We're going to call it intents. The whole thing is going to be called intents. And then we have a list of dictionaries. So we start with square brackets, and inside of those square brackets, we have individual categories. And these categories have three pieces of information. Three pieces of information. The first one is the tag of this particular category. Let's say, for example, the first one is greetings. And then we have the patterns. And the patterns are the examples of what a greeting would look like. Stuff like, hey, hi, hello, good day, and so on. So we specify a list of strings that will later on give the neural network examples of what it looks like to be greeted by the user. So we start with hello, hey, hi, good day. By the way, you don't have to care too much about case, about grammar, because we're going to reduce all of those words to the stems anyway. So we're going to tokenize them later on. So it doesn't matter if you say greetings with lowercase g or uppercase g, doesn't really matter. Greetings, what's up? Did I forget something? Hello, hi, hey, good day, what's up? Maybe something like how is it going? Stuff like that. And then we also have the responses. And as I already said, the responses are going to be hard-coded. So those patterns are going to serve as training data. So they are not going to have to occur in exactly that constellation here, but the responses are going to be the exact responses. So here we need to take care of grammar, take care of uppercase, lowercase issues, and so on. So we're going to say hello, or hey, or what can I do for you? And the idea is that once the neural network recognizes that the tag it's working with right now, so that the input was in fact greetings, it's just going to give a random response from that list. So it's going to be totally random. Sometimes it's going to say hello. If the user says greetings, it's going to say hello. Sometimes the user is going to say what's up, and it's going to say hey. Sometimes the user is going to say hi, and it's going to say what can I do for you. It's totally random. but the response is going to be exactly that. The user input does not have to be exactly what's up. It can also be what's up without that, so like that. Or it can be hi and hey, or something like that. And it's also going to be recognized. So this is more flexible. The responses are hard-coded. So now you can go ahead, be creative, and copy what we have just written and change it a bunch of times and introduce your own categories here. In this case, I have one for greetings, I have one for goodbye. Age, the pattern is always the same, or actually not the pattern in terms of patterns, but the pattern of defining categories is the same. You just copy it, specify a name for the category, then you specify some user input patterns, and then some static responses, and then you add a comma in the end, start a new one. And you can be creative and use your own categories. I have one for greetings, I have one for goodbye, for asking for the age, for asking for the name. In this case, the chatbot is called Neural. Then if someone asks for products and I want to buy something, what do you recommend? What are you selling? It goes to shop and gives a generic response here. Then when it asks, when are you guys open? What are your working hours? Hours of operation, 24/7. And then you can also add something like stocks. What stocks do I own? Which stocks do I own? And so on. And the good thing is you can not only do this with static text responses, you can also later on in the neural network, in the script, you can check if the category that was recognized is stocks. And in this case, if you don't want to return just a basic generic message, you can also execute a certain piece of code. So you can say, okay, if the tag I recognized is stocks, then go ahead, download the stock data and show it to the user. And you can also do it with something else. So for example, you can say tag shutdown. If you recognize that the user wants to shut down the computer, go ahead and shut down the computer, for example. So let's get started with the coding. First of all, we're going to create a training.py file because we're going to have one file for training the chatbot and a second file for using the chatbot. And since those scripts are going to be quite large, I'm going to look a couple of times onto my second monitor where I have the code already written, so that I don't make any mistakes and don't be confused by that. We're going to start with some import statements here. We're going to import random first for choosing the random response in the end. We're going to import JSON for obvious reasons. We're going to import pickle for serialization, and we're going to import numpy as np. If you don't have numpy installed, use pip to install it. Just open up command line, pip install numpy, like that. Then we use NLTK as well. Again, same thing. If you don't have NLTK installed, the natural language toolkit, you want to install it using pip. And then we're also going to say from nltk.stem import word net lemmatizer. Now this lemmatizer, what it's going to do is going to reduce the word to its stem so that we don't lose any performance because it's looking for the exact word. Let me give you an example. If we have the word work or working or worked or works and so on, this is all the same word. So we're not going to look for all these separate words. We're going to reduce them to the stem and they're going to be considered the same word, essentially. This is what the lemmatizer does in a nutshell. And then we're also going to import from tensorflow.keras.models. We're going to import the simple sequential model. Then from tensorflow.keras.layers, we're going to import a dense layer, an activation layer, and a dropout layer. And then we're going to import from tensorflow.keras.optimizers. We're going to use SGD, which is the stochastic gradient descent, if I'm not mistaken. Those are the libraries that we're going to need for this script. So we're now going to go ahead and lemmatize the individual words. For this, we're going to first create a lemmatizer here. Lemmatizer equals wordnet lemmatizer. And then we're going to load the JSON file. Intents equals json.loads. Open intents.json.read. So we're reading the content of the JSON file as text. We're passing that text to the loads function, and as a result, we get the JSON object, which is a dictionary essentially in Python. After that, what we do is we create 3 empty lists. First of all, the words that we're going to have, then the classes that we're going to have, and then the documents, which are going to be the combinations, the belongings, so to say. Documents. And after that, we're also going to specify the ignore letters. Ignore letters. Those are going to be the letters that we're not going to take care of, or not going to take into account. Let's put it that way. question mark, exclamation mark, period, and comma. There you go. And now we have to iterate over the intent. So we're going to say for intent in intents, because now you have to imagine that this thing here is a dictionary in Python. So now we have the intents, which is the object, and then we need to access the key intents. And there we have, for each intent, we have certain sub keys and sub values, so sub dictionaries, so to say. And because of that, we say for pattern in intent patterns. So for each of those here, for each of those patterns here, those are the patterns in the patterns list. For each of those, we're now going to say word list equals nltk.tokenize, and we're going to tokenize the pattern. Tokenize means that you're getting a text like, hey, I am John. And what tokenize does is it splits it up into the individual words. Hey, I am, and John. So this is what tokenize essentially does. We're getting a list of words, a collection of words, and we're going to add that collection of words to the words list. So to this list that we defined up here. And after that, we're going to also append it to the documents. We're going to say documents append, and we're going to append a tuple, first of all, of the word list, and then also of the classes, of the class of this particular intent. So intent tag. This is so that we know that this word list that we just appended to words belongs to this category, to this class, to this tag. And after that, we're going to check if this class is already in the classes list. So we're going to say if intent tag is not in classes, we're going to append it to the classes. Like that. And we can now go ahead and see what we get as a result here. Print documents in order to see if it works. Let's go ahead, and we got an error here. What is it? Line 24, word list equals nltk. Oh, sorry. Word tokenize is the function, not tokenize. Word tokenize. But now it should work. Another error. Append takes exactly one argument to given. I actually passed, oh, I didn't close the tuple, all right. Now we should be done. Let's see if it works. And we got another problem here. Oh, no, I didn't fix that problem. Okay, come on. It's getting ridiculous right now. We say append word list like that. Need to pass the tuple here. Now it should work. And as you can see, we get a list of hello, this is a greeting. Hey, this is also a greeting. Hi, this is a greeting. Greetings is a greeting. What's up is a greeting, and so on. And we get all the individual things in the documents list related to each other. Now let's go ahead and do the actual lemmatizing here. But before we do that, we need to fix two mistakes. And the first one is here we need to say words.extend instead of append, because extending means taking the content and appending it to the list, and appending means taking the list and appending it to the list. And this is not what we want to do. And also we need to call the constructor here, not just say word lemmatizer, we need to call the constructor of the word lemmatizer. After we've done that, we can say words equals list comprehension, and then we say lemmatizer.lemmatize the word for every word in words if this word is not part if this word is not in the ignore letters list. This is what we want to do. And then in order to eliminate the duplicates, what we're going to do is we're going to say words equals sorted set of words. Set eliminates the duplicates, sorted turns it back into a list and sorts it. And now we should be able to print this and see what happens. We should get a list of lemmatized words. And we do get one, as you can see. Can, good, goodbye, greetings, have, I, leaving, see, what. As you can see, all the individual words are now lemmatized, which is pretty good. So we can go ahead and also do the same thing for the classes. I mean, not lemmatizing them, but we can also say, I'm not even sure if we would need that, but I did it in the code. So classes equals sorted set of classes, but we shouldn't have any duplicates anyway. And the last thing that we're going to do here is we're going to save them into files. So we're going to say pickle.dump words open into words.pickle file as writing binaries. So we're going to save them for later on. And we're also going to do the same thing for the classes. So we're now getting into the machine learning part, and for this we need to understand why we're actually doing what we're doing in a second here. And the problem is right now that we have a lot of characters and words and classes and all of that, but those are not numerical values. We do not have anything that we can feed into a neural network. A neural network needs numerical values. We cannot just feed words into it and expect it to work on its own. We need to represent these words as numerical values. And in order to do that, we're going to use something called bag of words. We're going to set the individual word indices or the individual word values to either 0 or 1, depending on if it's occurring in that particular pattern. And then we're going to also do the same thing for the classes. Now, before I confuse you too much, let's get right into it. We're going to say training equals empty list. Then we're going to create an empty output or output empty, which is a template of zeros, and we need as many zeros as there are classes, so length classes. And what we're going to do then is we're going to say for document in documents, we're going to create an empty bag here. So for each of those combinations, we're going to create an empty bag of words, and we're going to say word patterns are what we find in the document at index 0. And then we're going to say word patterns equals list comprehension lemmatizer dot lemmatize word dot lower for word in word patterns. And that's actually it. We don't need to care about ignore letters. And then we're going to say for word in words. We want to check if that word so this words list is the one that we filled up here with all the words that occur in tense. For each word, we want to know if it occurs in the pattern. So we're going to say if word in word patterns, then what we're going to do, and we're going to write it in a different way here, we're going to say back append 1 if this word occurs in word patterns, and otherwise we're going to say back append 0, like that. And now we're going to do the same thing for the output. So we're going to say output row equals list output empty. This is what we do in order to copy the list. So we're not really typecasting it, we're copying it. And then we say output row equals, or actually output row classes dot index doc1. So the document 1, sorry. Want to know the class, which is at index 1, want to know the index, and then we're going to add to set this index in the output row to 1. And then we're going to append the whole thing here to the training list that we created. So we're going to say back and output row. And we're going to append it to the training list that we have here. So when we run that loop, all the document data is going to be in the training list. And we can work with this training list in order to train the neural network. Now we're going to do one final step of pre-processing before we get into building the neural network. And this is, first of all, we're going to shuffle the data. So random.shuffle the training data. And then we're going to also turn it into a NumPy array by saying training equals NP array of training itself. And then we're going to split it into X and Y values. Train X being training, or actually list of training everything and first dimension, 0th dimension actually. And the same thing for 1 and for the Y values. And those are the X and Y values, the features and the labels that we're going to use to train our neural network. So we can now start to build the neural network model by starting with model equals sequential. So we're going to create a simple sequential model here. And then we're going to add a couple of layers. And the first layer is going to be the input layer. It's going to be a dense layer with 128 neurons and an input shape that is dependent on the size of the training data for X. So we're going to say input shape equals length of the training data for X, index 0. Oh, come on. Like that. And then we also specify the activation function to be a rectified linear unit, the ReLU, so to say. Then we say model.add dropout in order to prevent overfitting. By the way, I'm not going to explain all the individual layers and functions and optimizers here because I don't think that this is the video where I should explain neural network theory to you. This is the application. So if you're interested in neural network theory, let me know down in the comments below. So I can maybe make a series about that, but now I'm not going to explain all the individual parameters and the individual functions and so on. After that, we again add another dense layer with 64 neurons and also the activation function of ReLU, rectified linear unit. Then another dropout layer, dropout 0.5. And in the end, we also want to have another dense layer, but this time it's going to be a little bit different. First of all, we want to have as many neurons as there are classes. So in a sense, just as there are training data inputs, training data elements, so to say, for the Y, for the labels. And then we also want to specify that the activation function that is used here is the softmax function, because that's the function that is going to allow us to add up the results. By the way, I think I'm writing outside of the bounds here. There you go. Yes. So now we say activation function equals softmax, because that's the function that sums up or scales the results in the output layer so that they all add up to 1, so that we have, so to say, percentages of how likely it is to have that output or that result, so to say, that label. Then we're going to quickly define a stochastic gradient descent optimizer by saying SGD. And then I'm going to enter a couple of parameters here that, to be honest, I don't understand all of them. Some of them I do understand, but as I already said, I'm not going to go into the theory here. So 0.01 is the learning rate. Then we have a decay of 1e minus 6. This is just another way of writing decimal places. Then we specify momentum of 0.9. And we're going to say Nesterov, I don't know what that is, to be honest, equals true. And now we go ahead and compile the model by saying model compile. The loss function that we're going to choose is called categorical cross entropy. And then we say optimizer equals the SGD optimizer that we just defined. And the metrics that we're interested in are accuracy, or is only accuracy. Then we go ahead and say model.fit, and we're going to use the training data, so np.array of the train X data here, actually without specifying an index. Then of course we want to have as an output the Y data, so train Y. And what we need to specify then are the epochs. We want to have 200 epochs, so we're going to feed the same data 200 times into the neural network in a batch size of 5. And last but not least, we're going to specify verbose equals 1 so that we get a medium amount of information. And in the end, we're going to save the model by saying model.save. And we're going to say Chatbot model.model or something like that. And in the end, we're going to print done. So now we're going to run this script here and see if it works. If everything went fine, we should be able to see the neural network being trained in a second. And for now, it looks good. Yeah, as you can see, it starts training 200 epochs and we are done. As you can see, the neural network is now trained. And the next thing that we need to do is we need to create a chatbot application itself that uses the trained model. So we start working in a new file, and here we also need to import the same libraries. So import random. We don't need to import the TensorFlow libraries, but other than that, we need to import the same libraries. Import random, import JSON, import pickle, import numpy as np, import nltk from, not frozen set, from nltk.stem, import wordnet lemmatizer. And then we're also going to say import pandas as pd, import, or actually no, we don't need that. This is for another project. Sorry, we don't need to import pandas. We only need to import TensorFlow from TensorFlow.keras.models. We need to import the method or the function load model in order to load the model that we have created with the training script here. So what we do then is we again create a lemmatizer. We say lemmatizer equals wordnet lemmatizer, and then we do the same thing. We say intents equals json.loads open. Actually, we can copy that from the training thing here. And then we also need to say words, classes, and model. We need to load them, and we've saved all of them. So we have words, we have classes, and we also have the model. So we say words equals pickle.load, and we open up the file words.pickle in reading binary mode. And we do the same thing with the classes. So we say classes equals pickle load, and then classes dot pickle. And the model is just load model chatbot model dot model. There you go. And now what we need to do is we need to set up a bunch of different functions, because the model is trained, we can already use it, but we need to use it the right way, because what we get is, again, numerical data, but we want to end up with words. We want to end up with what do I actually need to do. And for that, we're going to define 4 different functions. We're going to have a function for cleaning up the sentences, a function for getting the bag of words, a function for predicting the class based on the sentence, essentially, and then a function for getting a response. So we're going to start with the cleaning up of the sentence first. We're going to say def clean up sentence. We're going to have a sentence here, and we're going to say sentence words equals nltk dot word tokenize. So essentially, again, we're tokenizing the sentence. And once we have tokenized the sentence, what we're going to do is we're going to say, we're going to lemmatize the word. So we're going to say sentence words equals lemmatizer lemmatize word for word in sentence words. And this is it. And then we return those sentence words. And this is how we clean up a sentence. So the next function that we're going to write is called bag of words, and it's going to convert a sentence into a bag of words. So into a list full of zeros and ones that indicate if the word is there or not. So using flags, essentially, in the same way that we did it in training script already. So we're going to say def bag of words sentence, and then we're going to say sentence words. We're going to use a function that we defined above. We're going to say clean up sentence, and then we're going to create an initial bag full of zeros. How many zeros? As many as there are individual words that can be, because we need to set for each word, we need to set either 0 or 1. And then we're going to just say for word in, for W in sentence words, for I word in enumerate words, we're going to say back, or actually if this word here is the same as W, then we're going to say back I equals 1. Otherwise, it's automatically 0, of course. Return np.array. We're going to return a numpy array of the bag. So this is how we create a bag of words. So next we're going to define the predict function. We're going to make use of those two functions here for that. We're going to say def predict class based on the sentence. And we're going to say, give me a bag of words. Let's say bag of words is going to be bag of words of the sentence, because that's what we need to feed into the neural network. In order to get a prediction, we're going to say result equals model.predict. And we're going to pass a NumPy array of the bag of words. Do we need to, actually I need to pass it as a list like that, and then get the 0th index to match the format. So then we get a result, and then we can specify an error threshold that allows for a certain uncertainty. But if that uncertainty is too high, we're not going to take it into result. So threshold. And we can say this is 25% for now. So remember, we have the softmax function, which means that we have each position in the output is going to be a likelihood of that class being the result. And if this is below 25, we don't want to take this in. And in order to realize that, we're going to say result equals an index and the result itself for I are in enumerate the results, but only if R is larger than the threshold. So if the result is larger than the threshold. And of course we save the index so that we know which class it is. And then we're going to sort the results. We're going to say result dot, or actually results dot sort. The key for sorting is going to be an anonymous function, a lambda expression. If you don't know what it is, check out my Python tips and tricks tutorial series. And we're just going to take the first index every time and reverse equals true. So we're going to sort it in reverse order. So in descending order, essentially. And then we're going to have a return list. It's going to be empty, but then we're going to say for each, for R in results, we're going to say result list, return list dot append. And here we're going to say intent classes are 0. And then we're going to have a probability. This probability is going to be string of R1, of the index 1 of the result, because that is the probability. That is the actual result, and the first one is the index. And then what we get is, then what we do is we return the return list. So in a nutshell, what we do is we create a bag of words. We predict the result based on those bag of words. Then we have a certain threshold that we don't want to have too much uncertainty. What we do is we enumerate all the results so that we get the index, so the class, and also the probability. Then we want to sort by probability in reverse order. So we want to have the highest probability first, and then we want to have a return list full of intents and probabilities, so full of classes and probabilities. Now, actually, we need to fix two little mistakes here. First of all, when we train them all down here, we need to save it first into a variable and then save it into an H5 file and pass the return value of the fit function to save it into a single file, into an H5 file. Otherwise, it doesn't work. And second one is a little bit more stupid. We did pickle dump, and before that, it was saying words. I forgot to change it to classes, and because of that, it didn't work. And once we have fixed those two mistakes, we can run the chatbot, and we should be able to chat with this chatbot here. So yeah, I added a print up here for troubleshooting. We can remove that as well. And then, it says go bot is running. Okay, let's say hello. Let's see what happens. It says, hey, who are you? I'm Neural. What is your name, my friend? I'm Neural, the assistant of Florian. How are you? Okay, probably this was associated with how old are you, and therefore it tells me how old the owner is. I could also say something like, what are my stocks doing? You own the following shares. Then maybe we had buy. I gotta go. Okay, I gotta go is not recognized. Hi is recognized, I guess. Hey, what is up, bro? And as you can see, it has decent responses, I would guess. Or I would say, of course, you can improve it by adding more training data, more and more training data, more patterns, more responses, maybe even more text, more intents. But as you can see, we have built a simple, not so simple to be honest, but a decent chatbot in Python. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Of course, make sure you subscribe to this channel and you hit that notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and bye.